All right, so 91, we got that f is a polynomial function with this table, f prime of x, and these x values. And which of the following must be true for x between -2 and 6? Okay, so let's see what's going on here. F prime goes from 3 to 1, so it's decreasing here. Decreasing. Then from 1 to 4, it's increasing. Then from 4 to 7, increasing still, and then from 7 to 5, decreasing. Now let me make sure I mention this. It doesn't mean it's always increasing between there, because it maybe at 1, it maybe from when x is 1, it becomes, you know, like -5 or something. But I just mean the overall from 0 to 3, it's increasing, and from 3 to 5, it's increasing. So be careful about that point. Okay, so for A, it says the graph is concave up. So for it to be concave up, that means that the second derivative, or the graph of f, looks like this, and that the second derivative is positive, meaning that f prime is increasing. But it's not always increasing. You can see it's going to be decreasing at some point. So it's not A. It's not that it has to be true. The graph of f has at least 2 points of inflection. So remember, an inflection point is when the graph changes from concave down to concave up, or from concave up to concave down. So what happens is the graph changes from increasing to decreasing, or from decreasing to increasing. In this case, it would change from decreasing to increasing. In this case, it changes from increasing to decreasing. And I'm talking in terms of f prime. It changes its behavior. F prime changes its behavior from decreasing to increasing, or from increasing to decreasing. So it says there's at least 2 points of inflection. So you could see how it changes from decreasing to increasing. So there's at least one inflection point somewhere here, and then somewhere here. There could be more than 2, but there's at least 2, because it changes behavior at least twice. So B would actually be our answer. And let me just go over the other ones, explain why they're not. Must be true, f is increasing. Again, you don't necessarily know what's going on between. And it's decreasing some. You can already see some values, it's decreasing, but this is not guaranteed. If it said like f is increases at on some interval in this, you know, from -2 to 6, that would be okay. F has no critical points. It could. It's not guaranteed. Remember, it says must be true. It could, but it doesn't have to be true. And at least 2 relative extrema. No, as you can see here, it does for inflection points. It doesn't have to be relative extrema. Again, this could be possible, but it doesn't have to be true. Whoops, let me cross it out. So the answer is definitely going to be B. All right, last one for this multiple choice section. 92. Let R be the region in the first quadrant, bounded by the graph of y equals x squared, and above by the graph of y equals the square root of x. So let's draw a sketch of what this could look like. R is the base of the solid, and we want to find the volume of the solid with cross sections perpendicular to the x-axis being squares. So x squared, there's our graph of x squared, and y equals the square root of x. They would intersect at 1, 1. So here's our region. Here's our region R. And so what would happen here, cross sections would be that are perpendicular would be basically this length here. And since this is the side of a square, let's call this length S. You want to find an equation that represents, or an expression that represents the length for the side of the squares, for these cross sections here. What would give you those vertical lengths? And that would just be the top function minus the bottom function, or the square root of x minus x squared. And maybe if I can draw like a 3D rendering. I'm gonna try my best to see if I can. This helps. So think of this as y, x. This is like your third dimension, z. And what you're looking at, there's your square root function. Here's your x squared. Your cross sections perpendicular to the x-axis. This would be an example like this, something like this. You get this cool shape. Like a shrinking, not non-shrinking square curve thing. Whoops, it's gonna be something like that. So something like that. Anyway, so each side length is going to be the square root of x minus x squared, but the area of a square, remember, is s times s, or s squared. So the area would be just this expression squared, square root of x minus x squared, all to the second power. And so to find the volume, we just integrate this expression from 0 to 1. So we want to integrate this, so let's leave the start calculator. Let's go to the calculation screen. Numerical integral from 0 to 1. We got the square root of x minus x squared. And as long as I enter this correctly, let's see that. I actually get about 0.1285. And yeah, our answer would be A. All right. So there you go. So we're done with the multiple choice section. So I hope that helps. Good luck.